Hey there, hi there, ho there, welcome to Unit 3. Kind of a logical next step coming from plate tectonics. Now we're talking about earthquakes. So shifting plates can cause a number of different geologic processes to occur, including earthquakes. So that's where we go. In the previous unit, we touched on a little bit the different types of boundaries, and some of those boundaries where earthquakes are more common than others would be at, these are both convergent boundaries here. So convergent boundaries, think back to the Oreo cookies collisions, a lot of crumpling and collision and grinding. So you do get earthquakes at convergent boundaries, whether it's oceanic to continental crust and subduction zones, deep earthquakes and shallow earthquakes, or continental crust to continental crust collisions. Again, shallow earthquakes, deep earthquakes, earthquakes all over the place. Divergent boundaries as plates pull apart. Now, these are very fewer in numbers and more gentle, but you do get some earth movement and therefore earthquakes, but very typically very gentle and few and far between. And then transform plate boundaries, side-by-side motion, that grinding and movement next to one another, horizontal to one another. When those plates do slip, can release a lot of energy in the form of an earthquake, also shallow earthquakes. So you can get earthquakes, any boundary, convergent boundaries for sure, transform boundaries for sure, divergent boundaries, yeah, you do get some, but gentle and few and far between. So what are some of the basics when it comes to earthquakes? Well, an earthquake occurs when two blocks of earth suddenly slip past one another. The surface where they slip is called a fault. So you might have heard that word fault, for instance, the San Andreas Fault. Now, these faults can be at plate boundaries or break anywhere on a plate. So at plate boundaries, you can get some obviously movement of plates, some fracturing of material, creating movement between two blocks of crust, creating an earthquake, or sometimes breaks can happen in the middle of a plate. You don't necessarily have to be near a boundary, but you need break and movement. If the crust just breaks, you're not going to get an earthquake. You need break and movement, one side relative to the other, whether it's up and down, down and up, left and right, right, left, whatever it may be. When this break and movement occurs, energy is radiated out in all directions from this break. A lot of energy is released, and that radiates out in all directions, creating what we know as seismic waves. It's kind of like an ocean waves, but more propagation of energy, in which these waves kind of ripple kind of through the earth and on the surface of the earth. Just like if you were to throw a pebble, a rock into a still pond, you see all the ripples radiating out in all directions. Well, same thing with an earthquake, but in 3 dimensions. The seismic wave goes in all directions. In fact, seismic waves can travel back and forth through the entire earth from one earthquake event. If you are a type of geologist that strictly studies earthquakes and seismic waves, you are known as a seismologist or studies seismology. So, earthquakes typically occur below ground, whether it's a mile or 2 or 50 miles below Earth. That's typically where earthquakes occur, below ground. Where an earthquake occurs is called the focus of the earthquake. It's the origin of the earthquake rupture, and that's where the energy is released. Remember, they happen along a fault with a break and movement. So it's not just a break, it's a break and movement, whether that's at a plate boundary or away from a plate boundary. So the focus of the earthquake, that's where the earthquake originates from, where the rupture occurs, where the energy is released. Then you hear this term called epicenter. It's the type of term you hear on the news, in movies. Well, the epicenter is the point on the Earth's surface directly above an earthquake's focus. The epicenter of an earthquake receives the most energy. So if you're at the epicenter of the earthquake, you're at the spot on Earth directly above the focus. It's where the most energy, the most concentrated energy of the seismic waves will occur. The most damage and destruction will typically happen at the epicenter. As you get further and further away from the epicenter, the effects of the earthquake diminish. So those are a couple of terms: epicenter, focus, fault. Earthquakes typically also have aftershocks. If it's a very large earthquake, it could have excuse me, many aftershocks, as in hundreds, sometimes thousands of aftershocks. So aftershocks, again, something you may have heard in the news or in movies, are succeeding earthquakes after the main initial big earthquake rumble caused by subsequent stress along the fault lines. So once the break in movement occurs, there's still some smaller movement that might occur, and all of those after earthquakes are the aftershock. Example here. There was an earthquake, magnitude 7.5 on the Richter scale. More on that a little later in lecture. Was the initial shock, and then you can see all the many aftershocks, movement along that same exact spot on the fault line for well over a year into the future. So aftershocks can continue for a long, long time. So in the United States, what area has the highest hazard as it pertains to earthquakes? Well, some places obviously that are no-brainers. That makes kind of a lot of sense. California, we know there's a lot of earthquakes there. It's on the news all the time, so that's a very high hazard area. But also into Oregon and Washington, which sits along a convergent boundary. The small Juan de Fuca plate is converging, crashing into North American plate. The Pacific plate up here is crashing into the North American plate, so a lot of earthquakes in Alaska. Now, Hawaii sits in the middle of the Pacific plate, but it is volcanic in nature, so there is material rumbling and moving below ground, so there are some earthquakes there. This isn't how big earthquakes are. This is just where earthquakes can occur, the hazard associated with where they can occur. But some things that might not make sense, some weird ones. Look at in the middle, almost in the middle of the United States, Missouri, Arkansas, Tennessee area, high hazard. There's no plate boundary here. This earthquake hazard is in the middle of the North American plate. Same thing with South Carolina. Also in Oklahoma here, you have a little island, Oklahoma and Texas, of higher earthquake activity, and that's due solely to human processes and fracking. More on that later. So if we look at the global seismic hazard map, let's look at the dark red to browns. So very common along the west coast here of the United States, Central America, west coast of South America. If we look through here, kind of between India and Asia and the Himalayan mountains, kind of coming through Iran, through the kind of Middle East into Europe, down through Malaysia and Indonesia in this area, up through Japan. So these are your more high hazard, seismic hazard areas. Well, why is that the case? So again, let's kind of just think about, so kind of the west coast of North and South America, cutting through Asia and some of these Pacific islands as well. Let's take a look at an additional map. So this shows, again, earthquakes around the world. Again, you can see west coast, North South America, kind of in through Asia, as well as some of the Pacific islands. Well, all of these areas sit on plate boundaries, large plate boundaries. We have the circum-Pacific belt all around the Pacific plate, in which there's a lot of earthquakes, subsequently a lot of volcanoes. More on that in a later unit. Same through the Europe and Asia, the Alpine Himalayan belt. So these two areas, a lot of earthquakes because we're at plate boundaries. It's kind of hard to see, but the Alpine Himalayan belt, as it wraps around, kind of ends right here in Indonesia, as the circum-Pacific belt also meets here in Indonesia. So this area, just north of Australia, where Indonesia is, Malaysia, that area, is the confluence of two major belts of high earthquake activity, subsequently also high volcanic activity, sitting right at the edges of some major plate boundaries. So 81% of earthquakes occur along the circum-Pacific belt. 17% of earthquakes occur along the Alpine Himalayan seismic belt. And the remaining earthquakes are scattered in various areas of the world. So 81 plus 17, that's 98% of all earthquakes are either on the circum-Pacific belt, so around the Pacific Ocean and Pacific Plate, or the Alpine Himalayan belt. That leaves only, what, 2% anywhere else in the world. So these earthquakes are very focused. Indonesia, again, has the most earthquakes of any country each year on average. Again, why is that? I've shifted that previous image a little bit. We can see the Alpine Himalayan belt connecting with the Circum-Pacific belt. This is at the edge of some major plate boundaries here. Indo-Australian plate, Eurasia, Pacific plate. So the confluence here makes Indonesia a very, very dangerous, tectonically dangerous place to live. So that's where you're going to get the most earthquakes at any point in the year. So what about in Arizona? Where are earthquakes most likely to occur in Arizona? Now, this question is different than where are we most likely to feel an earthquake. The answer to that question, where are we most likely to feel an earthquake, would probably be somewhere on the western edge of Arizona because it would be closest to California. But that's not the question. The question is, where are earthquakes most likely to occur in Arizona? So under what area of Arizona do you think would have the most seismic activity in which the focus of an earthquake could occur? Where in Arizona might that be? Well, let's take a look. The answer is the kind of northern Arizona Flagstaff area. All of these blue lines represent faults. All of these green dots represent historic earthquakes that we have known to occur in Arizona. So you can see they have occurred around the state, historically speaking. But Flagstaff by far has the lion's share. A lot of faults up there, a lot of ancient, but now no longer volcanic areas up there, so there's a lot of extinct volcanoes in the northern Arizona Flagstaff region. Where there's volcanoes, there's material moving underground. Sometimes that material moving underground shifts things, moves things, creates earthquakes. So in Arizona, the area most likely to have an earthquake occur would be northern Arizona Flagstaff area. We're going to go ahead and take a pause right there. When we come back, we're going to talk about the different types of faults. There's more than just faults. There's different types. So we'll pause there, and I'll see you back here in just a minute.